Hello students. In the previous video, we started with introduction to absolute value inequalities. We also talked about and or inequalities. So let's just have a quick brush up of what we learned in the previous video. So for example, if you have an inequality like absolute value of x, say is less than 3 or less than equal to 3, how do you write the absolute value inequality as a compound inequality? What do? You copy down the x. If it is less than or less than equal to, you write x in between. If it is less than, just put less than and these kind of two symbols. And x is greater than something and x is less than something. And if it is less than equal to, so you put x in between these two symbols. After that, what do? You take the negative of this number and put it on the left hand side, and you take the positive of same number and put it on the right hand side. So that is how you change your less than inequality in absolute value inequality into a compound inequality. Similarly, if you have say x is greater than 4, and what will you do? Greater than, remember, is or. So how will you write it? X is, copy down the same thing without the absolute value sign. X is greater than 4, or x is, flip the sign, less than negative 4, negative of that number. Okay, once again, if it is a less than or less than equal to inequality, put x in between the negative of this number and the positive of this number. And if it is greater than inequality, that is how we are changing the absolute value inequality to a compound or inequality. So x is greater than 4, copy the same thing without the absolute value sign, or flip the sign, x is less than negative of that number, negative 4. How do you graph it? X lies between negative 3. So if this is your number line, so this is say a negative 3 and this is a positive 3. So x lies between, bubble in circle, in between the two, in between. Okay, what about this? Or, so that means you are going to draw the number line, and there is a negative 4 and there is a positive 4, and your x is greater than positive 4. It's not a bubble in, sorry, it's not a bubble in because it's just a greater than sign, so it's an empty circle, greater than 4, or x is less than negative 4, x is less than negative. So this is an OR inequality. The graph is in two opposite direction and going big, greater than, less than negative 4. And here it is confined in between, confined in between. So the graph is confined in between the two values. Okay. So now we are going to see how we're going to use Desmos to solve the absolute value inequalities. But before that, it's important to recognize how to write. We see a graph like that. If we type in some inequality in Desmos, say we see a graph like that, let's learn how to read that graph. Okay, read these numbers through which the end lines are passing. So this is negative 2, this is x is negative 2, and this is x is positive 2. And our solution, because it is an inequality, these are not just two lines like we saw earlier in when we were typing in equations in Desmos. So our answers were x is equal to negative 2 and positive 2. No, not this time, because we have the whole solution region inside, which is the answer to our problem. So how do we write down that inequality, the absolute value inequality, as a compound inequality? Compound is like or confined in between. So how do we write that inequality? Let me make it a little less messier. So what were these two numbers? I said this is positive 2 if you can't see it clearly, and this is a negative 2. How do you write? X lies in between negative 2 and positive 2. That means all the numbers in between, -1, 0, +1, 0.5, 1.5, any decimal real number in between is of value of x is your solution, and that covers this whole region. But because it is a solid line, you are going to put equal to sign. If you had seen a dotted line here in the ends, then you will not put the equal to sign. But solid lines means that number is also included. How do we write this inequality? If you see this is 2, this is 4, in between there is a 3. This is 6 and this is 7, exactly in between there is a 7. This is also an inequality that is confined between two numbers. It is a solid line, not a dotted line. So I'm going to put in between 3 and 7. So that's how when you type in your absolute value inequality in Desmos, if the graph looks like this, what is your answer? How are you converting your absolute value inequality into something like which does not have an absolute value? Is called compound inequality. So this is x lies between 3 and 7, and 3 and 7 are included. Okay, so let's go to, and similarly, if you see something like this, whenever you see a space in between, you type in OR. What does it mean? That x, this is a greater than, this is a less than. So x is greater than, go to the right, -2, or x is less than, what is it? -6. Greater than equal to because it's a, and this is less than equal to because it's a solid line. Okay, so you read these two numbers and all values of x greater than equal to, or all values of x less than equal to, there are two solutions. Similarly here, now you see that the line is dotted. So in this case, you read these two numbers 4 and this is 6. In between there is a 5. Here it's 0, -2, and in between there is a -1. So what's your answer? Whenever there's a blank in between, you write OR, and you have x is, first write the one which is going in towards the right. So that number was 5. X is greater than 5, or x is less than what? -1. This one is -1. So all values less than -1, or all values of x greater than 5, and I don't put equal to sign because my lines here are dotted. Okay, now let's practice some questions on Desmos. For example, go to Desmos and type in the inequality and write the solution set for the inequality. Okay, so we're going to go to Desmos and type in this inequality. So let's go to Desmos.com again, and there's beautiful free math. Click on that, graphing calculator, and here I'm going to type in the inequality, which is half of absolute value sign. So I go to the keyboard, and 2 minus x, absolute value close, minus 2 is equal to, what was that? Not equal to, it is an inequality, is greater than 2. Okay, so is greater than 2. Let me double check. That was the inequality. Half of 2 minus x minus 2 is greater than 2. Now, if I see it is a greater than inequality, if I see only one region, I can always zoom out and I can see my two regions, and you can clearly see that this is an OR inequality. I can just snip this part and show you. Um, me see if I can snip it and show you that this is -5, this is -6, and this is a +10, and in between there is space, so I'm going to write or. So x is greater than 10 or x is less than -6. And I could see that this is an or inequality, because in my question I have 2 minus x minus 2 is greater than. So if it is greater than, and when you see it is a dotted line, so you don't put equal to, so it is greater than 2, so I'm already expecting the answer to be greater than something or less than something. So x is greater than 10 or less than -6, and I'm going to copy that down. X is um, x is greater than 10 or or x is less than -6 was my answer. Okay, so I can even show here -6, and this was 10, and this was my shaded region. Similarly, let's do the next one, which is go to Desmos and type in the inequality 2x plus 3 is less than equal to 7. Okay, so I'm going here, 2x plus 3 is less than equal to. So all the symbols are there here in the keyboard, so that will be useful. And this is not half. There is 2x plus 3 is less than equal to 3. And we should have been expecting that, because look at this. This is a less than symbol. Less than means the answer is confined in between two values, right? And what are these numbers if you count? And this is -10. Here you see a -5 on the left hand side, and a -5 on the left hand side, and a +1 2 on the right hand side. Your solution region is confined in between, and it includes, because these are not dotted lines in the end, and this is an equal to sign on the left hand side. So your solution lies between -5 and +2. So that is what we're going to write, that your answer lies between x lies between -5 and -5 and +2. Okay, so that is the answer to this one, -5. So this was 2, and this was your -5, this was +2, and your solution region looks like this. Okay, so now write the solution set for the following. 17 and 18 are two slightly different questions. Look at this. This is a negative number out here. Can an absolute value ever be less than negative number? No, so the answer is no solution. So if you see a negative number on the right hand side and an inequality which is less than, and there is only absolute value present here of something, then the answer is no solution. Here you have to isolate first, isolate it on both sides, and you will have x plus 4 is greater than -8 plus 2 is a -6. And the answer is all real numbers, because absolute value of anything is always greater than a negative number. So the answer is all real numbers. So these two, now I wanted to discuss these two questions because they are slightly different.